Good morning. Listen, already yesterday, last class, we have discussed about these concepts. One is when the diode is forward biased. When the diode is forward biased, then the diode, if it is forward biased, means P variety connected to the positive, N variety connected to the negative. Then the diode, for all practical purpose, we are going to say it is conducting. Diode is conducting, we are going to say. And when the diode is conducting, current is flowing due to the majority charge carriers, it is more. Diode is conducting, current is flowing. Current is maximum. When the diode is reverse biased, means P variety connected to negative, N variety connected to positive, then we can say the diode is reverse biased. When the diode is reverse biased, current flow is very small. For all practical purpose, it is taken as 0. It is in terms of microamps. This is in terms of milliamps. Here to here 1000 times, this is smaller. This is 1000 times, it is larger. This is in terms of milliamps. This is in terms of microamps. Very small amount of current, approximately taken as 0. Therefore, when the diode is reverse biased, we are going to say the diode does not conduct. When the diode is forward biased, we are going to say diode is conducting, we are going to say. So based on all these concepts, whatever we have learned so far, okay, let us take up today's first concept. What is that? Okay, listen now. Current can be divided into two categories. One is majorly, of course, okay, broadly if you are classifying, the electric current can be divided into two categories. One is DC current, direct current, steady current. The other one is alternating current, AC. DC current, always a voltage is said to be a constant voltage. If I want to show it by using a graph here, I will show the graph in both the cases, just to see that. Okay, here the graph, this is the graph for DC. This is steady DC, of course. Variable DC, if I want to show it, I can show it like this. This is variable DC. This is variable DC. Voltage is increasing, decreasing. Voltage again, it is increasing, decreasing like this. This is variable voltage. This is constant voltage, steady constant voltage. Here voltage increasing, decreasing, 0. Again increasing, decreasing, 0 like this. But alternating currents are not like that. Alternating current is like this. This is alternating current. Voltage is increasing, decreasing. Reverse is direction. Again reverse is direction. Increasing, decreasing. This is increasing, decreasing. Increasing, maximum, decreases. Again here, increases and decreases, but reverse is direction. Here the direction is constant. Okay, the direction never change here, but here there is a change in the direction. Direction, every half cycle is go on changing the direction. Polarity is go on changing. DC we are writing like this. DC, if you want to show it, we are showing like this. This is a DC source. This is a DC source, positive, negative. This is DC source. Battery, cell, or a battery is a DC source. AC source, we are writing like this. This is a circuit symbol for AC source. This is DC source. AC source, we are writing like this. Alternation must be there here. Alternation means once in a way it is increasing, decreasing, and changing its polarity. Here we should not write positive, negative. Here we are supposed to write positive, negative. Polarity we are supposed to show it. And the current starts to flow from positive to negative. Here is not like that. Once the current is flowing like this, next the current is flowing in the reverse direction, again reversing, again reversing, again reversing like this. The current is, I can say, alternately it is go on changing the polarity. That's why it is called by the name alternating current. So in the case of alternating current here, if I'm writing a graph, maybe this is a graph here, like this. This is called by the name positive half cycle of AC. Positive half cycle of AC. This is called by the name negative half cycle of AC. Together is said to be one cycle of AC. This is one cycle of AC. Here to here, it is one cycle. 1 hertz, one cycle. Out of that one cycle, this is positive half cycle. This is negative half cycle. Once it is reaches here, polarities go on changing. Means positive, negative, it is not existing here. Current direction is go on changing. Next half cycle, current starts to flow in the reverse direction. That's why it is called by the name alternating current. So without these ideas, we cannot go further. For that purpose, I taught a little bit regarding the DC source and AC source. Okay. AC cannot be studied for us. AC cannot be studied. At home, whatever we are using, it is AC only. AC cannot be studied. If it is AC study, is not called by the name the alternating current. That is called by the name the DC current. If you are using a battery here, a cell or a battery, I can say, this is producing a DC current. This is producing a DC current. Okay. At home, whatever we are using is AC. But your mobile chargers are there now, mobile chargers. The adapter is connected to AC. But output is said to be the DC. Output is the DC. But whatever we are connected to the wall plug, that is AC. AC to, it is coming out. DC, it is coming out. So we want to convert AC in the form of DC. Don't forget, we want to convert AC in the form of DC. That's our intention. We want to convert AC in the form of DC. Now the first concept, out of this, the first concept, hoping that you have understood about this. What is the next idea here? So first concept, what do you mean by rectification? One more question. Rectification means what? We want to convert AC in the form of DC, we want to convert. We want to convert alternating current in the form of direct current. That process is called by the name rectification. This process is called by the name rectification. One more question. What do you mean by rectification? The process of converting alternating current in the form of direct current, AC to DC. If you want to convert, there is a process here. That process of conversion of AC to DC is called by the name rectification. Now, what do you mean by rectifier? What do you mean by this rectifier? If at all, if you want to convert AC to DC here, we are using some instrument here. We are using some instrument, the devices we are using, the device is called by the name rectifier. The process is called by the name the rectification. That device, that instrument used to convert AC to DC is called by the name rectifier. According to your syllabus, the rectifier can be divided into two categories. There are so many types of rectifiers are there, but broadly it has been classified into two here. One is called by the name half wave rectifier, only positive half cycle only converting in the form of DC. Positive half cycle converts in the form of DC. Next one, full wave rectifier. Whole cycle, positive half cycle, negative half cycle, both are converting in the form of DC. This is also converts in the form of DC. This also converts in the form of DC. Then it is called by the name full wave rectifier. Otherwise, only positive half cycle is converted, is called by the name half wave rectifier. Whatever we are learning now, this year, it is outdated syllabus actually. This one. Whatever we are using now, it is outdated. Practically, we are not using these circuits. We are using the bridge rectifier circuits, which is not in our syllabus. Bridge rectifier we are using in your mobile phone chargers and AC to DC. Whenever if you want to convert, we are converting like that using a bridge rectifier, using the 4 diodes we are using the 4 diodes in the form of a bridge circuit we are doing. But here we are using 1 diode. You are aware of what is diode. Here we are using 2 diodes. Half wave rectifier we are using 1 diode. Full wave rectifier we are using 2 diodes. We are not using 4 diodes. 4 diode circuit, it is not present in your syllabus. That is the bridge rectifier circuit. Here the efficiency is equal to 40.6%. Efficiency, output efficiency. Here the efficiency is 81.2%. More than this, 81.2%. This is the efficiency. Efficiency of half wave rectifier 40.6%. Efficiency of full wave rectifier 81.2%. Okay, this is about the basic idea. Rectification, it is a process of converting AC in the form of DC. Rectifier is a device which is used to convert AC in the form of DC. Rectifier can be divided into 2 categories: full wave rectifier, half wave rectifier. Half wave rectifier, full wave rectifier. In the case of half wave rectifier, we are using the 1 diode, and where the efficiency is very low, 40.6% output. In the case of full wave rectifier, we are using the 2 diodes, where we are using 81.2% of efficiency we are getting here. We are not using the bridge rectifier at this level. Okay, first one by one, both are important. This is the first one, this is the second one. Both are important for your final exam. Okay, what is that half wave rectifier? First one. Today we will discuss about the half wave rectifier, if possible full wave. Otherwise tomorrow I will explain that. The first condition, half wave rectifier. Half wave rectifier, where we are converting positive half cycle only in the form of DC, negative half cycle, this circuit could not be able to convert. This is the first concept. Okay, what is happening here now? Circuit, everything that I supposed to explain. So you are aware of a diode. You know already about a diode. The diode is representing like this. This is a diode circuit symbol. Already we are aware of that. This is P and this is N. This diode, it will not work for a larger voltage. If you are applying a larger voltage here, at home we are using the 230 volts AC. 230 volts AC we are using at home. This voltage, accidentally, that if you are connecting here now, then this diode is going to be burning out. Smoke, it will start, it will becoming blackening here, and it will not going to get work further. It is going to get spoiled. So we cannot apply 230 volt supply here. We have to supply only the lesser voltage. A diode, semiconductor diode, it will not work at a very high voltage of the order of 100 volts, 50 volts. It will not work. It cannot. Okay, therefore, we are using 230 volts AC supply. We cannot supply here, but 230 volts AC, we are reducing that one to maybe 5 volts AC. Reduce. If you want to reduce 230 volts AC to 5 volts AC here, we are supposed to use a transformer. Step down transformer. Higher voltage of AC to lower of voltage of AC. If you want to convert here, we are supposed to use a step down transformer. We are using a step down transformer. Then only AC to AC only it will convert. Transformer, it works only under AC. Transformer, it will not work under DC. Why? I will explain that one in the AC theory. There I will going to explain. So here we want to convert 230 volts AC to 5 volts AC. It does not convert in the form of DC, AC only. But higher voltage of AC to lower of voltage of AC we want to convert. If you want to convert here, we require a transformer here. The transformer is called by the name step down transformer. It is a step down transformer. Using that, we are converting 230 volts AC to 5 volts AC, higher voltage of AC to lower voltage AC, we are converting. Then we are feeding this one. Then we are going to convert this 5 volts DC. This here we are going to use a rectifier. Here we are going to use a rectifier where AC to DC we are converting. There we are applying, or we are going to supply this voltage here, and further we are going to get 5 volts DC. What we are going to do? So first of all, we have to use a transformer. Then we are supposed to use a rectifier that is called by the name the full wave rectifier. So what is that? Step down transformer means there are iron cores are present here. I am showing the iron cores. If I am writing the lines here, the lines are representing the iron cores. This is iron core, and here there is a coil present here. Now the coil, step down transformer, this coil number of winding is said to be more here. This number of winding is more because it is a step down transformer. Here the number of windings are less. Lesser number of windings I had to show. This is step down transformer. This is called by the name the primary coil. This is called by the name the secondary coil. Primary coil number of turns are more. Secondary coil number of turns are less. Then it is called by the name the step down transformer. Higher voltage to lower voltage. Using this transformer, we are supposed to convert. So whatever I have written so far, it is a step down transformer. Here we are connecting, here we are connecting 230 volt supply. At home, the plug is there now. That plug we are going to connect here. Now this connection is whatever it is said to be as 230 volts AC. AC connection that we are going to put. Now this transformer 230 volts AC supply, it is reducing. 230 volts AC supply, it reduces to maybe 5 volts, 10 volts. Different transformers are available, no problem. It can reduce us to 10 volts, it can reduce us to 12 volts, it can reduce us to even 20 volts, it can reduce us to 2.5 volts, it can reduce us to 3 volts, depending upon the number of turns here. That is a step down transformer. High voltage to low voltage, it is converting. Now, I will consider this point is said to be taken as A point for our references, for our study purpose. This is taken as B point. This point is connected to a diode. Already you know about a diode. This is a diode I am connecting. Then we are connecting a resistance here. Resistance is representing like this, zigzag way. It is resistance called by the name load resistance, RL. L, load resistance. Load in the sense a larger resistance. A larger resistance is called by the name the load. Electronics, it is not called by the name the larger. It is said to be taken as load. We have put a load, we are going to say. We have connected a load here. Load means the sense a resistance we have connected. A higher resistance we have connected. A larger resistance we have connected here. This is P. This is N. This is the circuit idea. This is a circuit concept. If you are writing this much, you will get 1 mark. If you are writing this much only, you will get 1 mark under this half wave rectifier. Okay, this is the way that we are going to put the scheme of evaluation. Okay, circuit diagram is written, put 1 mark. Output waveform, input waveform is written, give 1 mark. Then explanation, maybe 2 marks, 3 marks, 1 mark, like that it has been divided. Depending upon that year, how many marks it has been asked. Usually we are asking this question for about 3 marks. Under 3 marks question we are asking. Okay, a teacher is having soft corner, he may ask this question for about 5 marks. Half wave rectifier, here there is a transformer, it is a step down transformer. Here there is the iron cores are present here. Number of turns are more here. Here the number of turns are less. We have connected 230 volts AC supply here. The 230 volts AC supply, we are reduces to a lesser voltage here, maybe 5 volts, 10 volts like this. This is taken as, okay, right, this point, some occasion it is positive, some occasion it is negative. Once in a way it is positive, this is negative. I already told you about this. This is the AC graph. This is the AC graph. This is positive half cycle of AC. This is negative half cycle of AC. So during the positive half cycle of AC, this is positive, this is negative. Current is flowing like this. During the negative half cycle, polarity is going to go on changing. The polarity is go on changing here like this. During the positive half cycle, this is positive, this is negative. During the negative half cycle, reversing the polarity, this is negative, this is positive. If the polarity is present like this now, then during the negative half cycle, polarity becomes like this. During positive half cycle, polarity becomes like this. During negative half cycle, again the polarity changing. Polarity in the sense positive, negative, it is go on reversing. At home, whatever we are using the frequency here at home, that is equal to 50 hertz. Means imagine in 1 second, this polarity is changing 50 number of times in 1 second. 50 with, in 1 second it is changing 50 number of cycles. 50 number of times the polarity is go on changing. That is the frequency. That is called by the name the frequency. So anyhow, this is positive, this is negative during the half cycle, positive half cycle of AC. During the negative half cycle of AC, this will becoming negative, this will becoming positive. So one by one, I will going to select now. So what is happening here? In this case, during the positive half cycle of AC, this is acting as positive, this is acting as negative. I said during the positive half cycle of AC. So I can show it like this now. Okay. During the positive half cycle, what is happening? Okay. I will write it here. Let it be there like that. You can see that. Right. Okay. During the positive half cycle of AC, what will happen? During the positive half cycle of AC, what is happening here? During the positive half cycle of AC, I told you already, A is said to be taken as positive. A is acting as positive. A is positive. B is negative. B is acting as negative. Yes, A is positive, B is negative here. A is positive, B is negative here. P connected to positive. See that P connected to positive, N connected to negative. Yes, P variety of a diode connected to positive, N variety connected to negative. This diode is said to be forward biased. Therefore, I can say the diode is forward biased. It is forward biased. As the diode is forward biased, diode conducts. Diode conducts. As the diode conducts here, current flows. As the current is flowing here, high school level already you have studied about the Ohm's law. As the current is flowing here, current into resistance, you are going to have the voltage. So therefore, across this one, you are going to get a voltage. Across this, you will get a voltage. This is V output, I will going to say. V out means V output, output voltage. This is output voltage we are going to get. So therefore, across RL, there is an output voltage. There is an output voltage across RL. Therefore, you are going to get a voltage here. That voltage, I supposed to show it here. This is input and this is output. I had to show it. This is input wave. I will going to show it. The input wave is like this, AC. Like this. Output wave, I supposed to show it here. This is input wave. This is output wave. So output, this is positive half cycle. Positive, I will show it like this first, then I will show it. What is happening in positive half cycle, what is happening in negative half cycle, I had to show it. For that purpose, I am showing like this. Okay. This is output and input form, output form that I had to show. Coming back here. Here A is during the positive half cycle of AC, what is happening? A is positive, B is negative. A is positive, B is negative. P connected to positive, N connected to negative, therefore diode is forward bias. As a diode is forward bias, current starts to flow. As a current is flowing here now, current into resistance is the voltage. Current into resistance is the voltage. V is equal to IR, Ohm's law. Ohm's law, V is equal to I into R. Current is flowing here. I multiplied by R is equal to voltage. Therefore, you are going to get a voltage here. If you are connecting a voltmeter, you are going to get that voltage. It has been shown by that voltmeter. Therefore, current flows across RL, there is a voltage. There is an output voltage. I have to show that output voltage here. I supposed to show the output voltage here. This output wave, output voltage, I supposed to show it. See there, this is the output. This is DC. Of course, variable DC. Of course, it is variable DC. It is no longer it is helpful for our practical purpose. You cannot use for your mobile phone. You cannot use for your radio or something else. We cannot use this. If it is a constant DC, steady DC, we can use it. Sir, if you are using this, what will happen? Once in a way, voltage is 0. Then voltage is maximum. Voltage is 0. Then your mobile phone or whatever, for whichever the instrument, if you are connecting this voltage, it will work, it will stop. It will work, it will stop. We don't want. We want to have the continuous working. If that is the case, we have to, okay, we are supposed to cut down this one and we are supposed to do it as a constant DC, steady DC. For that purpose, we are using the clipping circuits. Higher classes, we are going to study about that. We are connecting a clipping circuit, clamping circuits. All these ideas are there. Okay, this is only a rectifier. Filter circuit, we are not doing here. RC filter, pi section filter, T section filters, okay, LR filter. There are so many types of filters are available. Filters in the sense not your chemistry filter, it is current filter. Okay, anyhow, this is output wave. We are going to get the output. Not yet over. Still, see here, this is during the positive half cycle of AC. During the negative half cycle of AC, what is happening? During the negative half cycle of AC, what is happening? Everything is reversing. During the negative half cycle of AC, during this negative half cycle of AC here, this is acting as negative. This is acting as positive. Positive becomes negative, negative becomes positive. If this is acting as negative and this is acting as positive here, now P connected to negative, N connected to positive. As P connected to negative, N connected to positive here, diode is under reverse biased. As a diode is under reverse bias, here the current is flowing, but it is very, very, very smallest amount of current due to minority charge carriers. That current approximately taken as 0. If the current is taken as 0 here, diode does not conduct. As the diode does not conduct, here no current, I is approximately 0. As I is equal to 0 here, current into resistance is the voltage. As the current is 0 multiplied by this resistance, voltage is also equal to 0. Therefore, you are going to get the voltage here, it is equal to 0. Here you are getting the voltage is equal to 0 volts. Here there is a voltage, increasing, decreasing, but here there is no voltage. Voltage is equal to 0. Okay, that I will going to write it here. Okay, during the negative half cycle of AC, what is happening? A becomes negative, B becomes positive. A becomes negative, B becomes positive. Everything is reversed. A becomes negative, so A is negative, B is positive. Therefore, diode is reverse biased. As a diode is reverse biased here, therefore I can say implies diode does not conduct. As the diode does not conduct, here current approximately equal to 0. No current flows. As there is no current is flowing here, I can say this implies across RL there is no voltage. There is no output voltage. There is no output voltage. Output voltage is equal to 0 here. Therefore, output voltage here it is equal to 0. Again, next case. This is during the positive half cycle. During the negative half cycle, this is happening. Again, we are getting positive half cycle. Again, if we are getting positive half cycle here, during the positive half cycle, A is positive, B is negative. Diode is conducting. As a diode is conducting, current is flowing. As a current is flowing here, there is a voltage. Therefore, here you are going to get a voltage. During the negative half cycle of AC, this is negative, A is negative, B is positive, P connected to negative, N connected to positive. Therefore, PN junction diode is reverse bias. As a diode is reverse bias, current is 0. As current is 0, voltage is also 0. So here the voltage is 0. No voltage. Again, during the positive half cycle of AC, A is positive, P connected to positive, N connected to negative here. This is forward bias. Current is flowing. Current into resistance is a voltage. You are getting a voltage here. You are getting a voltage here. So see here, actually, you are getting positive cycle as it is. Negative half cycle, it has been cut down. You see that? It has been removed. This negative half cycles, it has been cut down and it has been removed. If it is removed here now, it is appears as it is only the DC. You can observe that the AC means the negative half cycle is also present. But here the negative half cycle, it has been removed here. Only positive half cycle we are getting. But here the voltage is 0. Therefore, voltage is not continuous here. The voltage is not continuous. Here there is a voltage. Of course, that voltage is also not constant. Increasing, reaches maximum, decreasing, reaches 0, then no voltage at all. For some time interval, no voltage at all. Again, the voltage is go on increasing, reaches maximum, then it is go on decreasing. Again, the voltage is equal to 0 here. Again, up to a particular time interval, voltage is 0. Then again, the voltage is go on increases to maximum, then decreases to 0. It will happen like this. This output voltage is called by the name pulsating DC. One mark question in one of the CET examination, they ask this. What is the output of half-wave rectifier? The output of half-wave rectifier is, the output of the half-wave rectifier is not a continuous DC. It is called by the name the pulsating DC. It is said to be just like our pulse. It is not continuous. If you are holding the pulse here like this, it is not continuous. Once in a way, one electric pulse like this is coming. Again, there is a stop. Again, it is go on increasing. Like that, it is happening here. It is called by the name the pulsating DC. So therefore, the output waveform is a pulsating DC. The output waveform is a pulsating DC. This is an input. Okay, now, if they are asking for 3 marks question here, this circuit, it carries 1 mark. These two carries 1 mark. You have to write input and output, otherwise it is meaningless. This carries 1 mark. And some occasion we are asking this idea, this carries 1 mark. So here transformer we are using only to reduce the AC voltage to AC only. Higher amount of AC voltage to lower amount of AC voltage we want to convert here. For that purpose we are using a transformer here. If you don't use a transformer, diode, it cannot tolerate the high voltage. It can reduce that. AC to DC it can convert, but only the lower voltage of AC to lower voltage of DC it can convert. Okay, but